Hello everyone, welcome back to our channel Geomatics Engineering. First of all, we are very sorry for late uploading this video. Actually, we faced some technical issue and some terms and condition issue. Finally, we fully solved it. Now we can assure you we will complete our course and all rest of lectures on or before November 2022. Let's start our today's content, which is coordinate system. Okay, everybody I think know about the basic knowledge about the coordinate system. In 10th standard, there was some mathematical problem where we have to measure the coordinate point and the distance from one coordinate to another coordinate. So I think everybody will know about some basic information about the coordinate system. The first question come in your mind: what is coordinate system? Coordinate system is a system for tuple of numbers to each point in an n-dimensional space. Okay, what does it means? Means using this coordinate system, we can locate a point or identify a location using some number method on some n-dimensional space. Like for 2D, we estimate that location point using two numbers, which is x and y. For 3D, it's x, y, z, this type of things. And the location point identify on the graph or grid. Now, type of coordinate system. There are various type of coordinate system available for represent the location point. Okay, but all of them fall into some broad categories. The number of broad categories are two, which is number one is curvilinear and number two is rectangular. What does curvilinear means? What does curvilinear coordinate system means? Using this curvilinear system, we can locate a point by measuring angle. Okay, means measuring angle we can locate a point. But in this rectangular coordinate system, we used to measure distance for locating a point. The example of curvilinear is geographic coordinate system, and for the example of rectangular coordinate system is Cartesian coordinate system and projected coordinate system. Now, if we describe this example, then you can easily understand what is curvilinear coordinate system and how it's work, and what is rectangular coordinate system and how it works. First, we come to the Cartesian coordinate system. Actually, we use this type of coordinate system in our basics, where there was 2 point x and y, and using that x and y point value, we can estimate the distance, area, perimeter, and the location point, this type of things. So, using this Cartesian coordinate system, uniquely determine each point in the plane through the two numbers, which is x and y. Okay, this direction of x represent a positive value, and this direction is negative value. This direction of y represent a positive value, and downward direction is represent negative value. It is a 2D representation, and the joining point of the x and y axis is known as origin, which I mention here as O. This is the origin point, and there are 4 quadrant. This is quadrant number 1, this is 2, this is 3, and this is 4. Okay, if there is a point or location P is present in first quadrant, okay, then the point location value is x and y, and the value is both positive. But when it present in second quadrant, the value type is negative and positive for x and y respectively. And when it's come in third quadrant, both are negative for x and y, and when it comes in 4 quadrant, then it positive and negative for x and y respectively. Okay, now we come to the geographic coordinate system. Actually, geographic coordinate system express every location on the earth by two of three coordinate system of the spherical coordinate system. Now, one question in your mind, what is spherical coordinate system? Like, this is a sphere, this is a sphere. Okay, suppose this is a sphere, and this point is you have to locate this point using spherical coordinate system. There is coordinate. How can we measure? For measuring that, we have to know about this spherical coordinate system or 3D coordinate system. For 3D coordinate system, we draw x, y, and z axis. Okay, and this is a point. For Cartesian, we can easily know the point value is x, y, z. But when it's come into spherical field, then the value is r, phi, and theta. What is r? R is the distance of the point from the origin. What is phi? Phi is the angle from the x-axis, positive x-axis. And what is phi? Phi is the angle from the positive z-axis. Everything measured from the positive side. I think we everybody know this. But when it's come into geodesy field or geomatics field, we know about latitude and longitude. If anybody did not know about this latitude and longitude, what is latitude and longitude, please go to our previous video. There I mention and describe the latitude and longitude briefly, and also how to measure the latitude and longitude value of a point on Earth's surface. I described there. Please go to that video and then come to this video. Okay, so like on the Earth's surface, this is a point. Okay, for measuring the location of the point on the Earth's surface, we have to use latitude and longitude. For this, the longitude value is this angle and the latitude value is this angle. Using this latitude and longitude value, we can estimate the location point value on the Earth's surface of that point, which is known as geographic coordinate system. Okay. Now datum. Datum is a important component for geographic coordinate system. Datum is a reference point from measurement done. Like if we measure some height value, okay, we have to know the point location value, which is known as benchmark. The height of this benchmark we known previously, or some data will be given, and this is another point. If we measure the height of this point, so we can measure the height value from this point. So for that, the reference point is this, and if we may have to measure the distance value, then also the reference point is this. For every measurement, we have to take a reference point, and that reference known as datum. Here the in geodesy field or geomatics field, the geodetic datum comes in. In the surveying and geodesy, a datum is a reference point, okay, on the Earth's surface, against which position measurements are made, and also an associated model of the shape of the Earth for computing position. Like every previously I mentioned, for height, distance, everything we have to know about the information about datum. Okay, so for that reason, here comes datum, and using this geodetic datum, we can know about the positional information of a point on Earth surface. Okay, in geodesy there are two type of datum. Number one is horizontal, number two is vertical. Okay, so how is used? Horizontal datum used for describing a point on Earth surface. It is used for describing a point. Okay. But by which? By latitude and longitude. Okay. But for the vertical datum, we used to measure elevation. Right? For underwater depth also, and surface height and the height of object. Okay. The example of this datum is like WGS 1984, which is the most modern datum developed. Okay. It is mostly used recently developed datum, and also there is Everest India and Nepal datum. Everest India and Nepal datum. There are also Indian 1975, 1954. This type of datum is present. Okay, but for WGS 1984, there is geocentric data comes in. What does it mean? Geocentric datum use the Earth's center of mass as origin. Like CG point, it's take the CG point of Earth as origin. Okay. From here, we estimate the distance, height, the all measurement. Okay. This is geocentric datum. Now comes to the projected coordinate system. From the name, we can assume which type of coordinate system it is. Actually, in this coordinate system, we project 3D surface to 2D surface. Okay, it is a 2D surface projected coordinate system, and using this projected coordinate system, we can measure length value, area value, angle, perimeter, etc. Okay, it is always based on the GCS, on a sphere or a spheroid. Like this is Earth surface and this is a spheroid surface. For estimating the location point on the Earth surface, we use GCS for 3D. But we have to project this GCS to PCS, projected coordinate system. For measuring length, area, angle, perimeter, this type of measurement, we have to project it into 2D, and the GCS comes to PCS. Okay, when it's in 3D, it's known as GCS. When it's come to 2D, it's known as PCS. In a PCS, locations are identified in XY coordinates on a rectangular grid, and there was also a origin from where the measurement done, which is known as center of grid. One thing I have to mention here, using GCS, we can't or we never estimate this type of things. We never. Okay. We never estimate this length, area, angle, or perimeter measurement using GCS. If we want to estimate these things, we have to convert the GCS to PCS, projected coordinate system. Okay. Next, which type of coordinate system used for survey? Actually, survey is a part of this geomatics engineering. If we see the syllabus, there was survey portion, and the coordinate system used for the survey measurement is Cartesian coordinate system and polar coordinate system. In Cartesian coordinate system, the measurement will x and y value, and for polar coordinate system, it will r and theta. R equals to root over of x square plus y square, as we know, and theta equals to tan inverse y by x. There are two questions which is very important for the exam. Number one is, which type of coordinate system used for total station? Okay, total station is an instrument for measuring the distance, area, perimeter, which we used for the survey measurement, and the coordinate system used for the total station is polar coordinate system, which comes under the rectangular coordinate system. And this total station, and using this coordinate system, we can estimate the vertical distance, horizontal distance, height of the object, which known as altitude, also latitude, northing and southing, departure or easting and westing. This is a defined term. Okay, there is theoretical term, there is a practical term. For various purpose, we use various term. Okay, this is the same thing with various term. Next week comes second important question, like which type of coordinate system used for GPS. Everybody we heard about the GPS. That I think that portion will covered in your GNSS and or remote sensing module. GPS works in the geographic coordinate system, which is comes under the curvilinear coordinate system, and this type of coordinate system provide a latitude of longitude value of a location. Okay, this is the all things about the coordinate system, and the most important question will come from this coordinate system. Please go through this coordinate system very deeply, and also go through our lecture, which is also present in our channel, please. So thank you everyone. If you are new to our channel, please subscribe our channel and support us.